All right, so in this video, we're going to see how we can use Desmos to get a linear regression. A linear regression is just the word for the process of finding the line of best fit. So the linear regression gives us the average of a data set. To do that, we're going to use this data over here, which measures the years since 1999 and the percentage of people who didn't get a dental procedure because of insurance. So since it's 1999, we're going to say that it's year 0 because it's been 0 years since 1999. So I'm going to put 0 in my table, and I'm going to put 7.9 in my y-axis. I'm going to put, for 2000, I'm going to put 1 since it's been 1 year since 1999, and 8.1 for my percentage. In 2001, which was 2 years after 99, it's going to be 8.7. 2002 was 3 years after, that was 8.6. 2003 was 4 years after, that was 9.2. 2004 was 5 years after, that was 10.7. And I can just hit enter to get a new row. 2005 was 6 years with a percentage again of 10.7. 2006 was 7 years with a percentage of 10.8. 2007 was 8 years after with a percentage of 10.5. 2008 was 9 years after 1999 with a percentage of 12.6. And 2009 was 10 years after 1999 with a percentage of 13.3. So Desmos makes your scatter plot for you. The linear regression adjusts as you change your data. And if you scroll down, it'll give you your trend line. They use that approximation symbol because it's an estimate for the data, but they give you your parameters down here. So the equation of the trend line, if we were rounding to the nearest hundredth, would be y equals 0.51x plus 7.54. It also gives you r squared and r. R squared, remember, tells us if a line is the right shape for the data. So is this a linear scatter plot, a linear correlation, or is it a nonlinear scatter plot? Since it's close to 1, we know that a linear scatter plot would be the right shape. And then R tells us about correlation. It tells us if it's positive or negative and if it's strong or weak. So since R is positive 0.95, we know that it's a positive scatter plot, which we can see. And since it's close to 1, we know that it's a pretty strong correlation. The really nice thing about this as well is it also gives you the residuals. So if you click plot, it'll add this new row or new column into the table. And so it tells you the residuals for each of these. So in 1999, we were 0.35% above average. In year 1, we were almost exactly on average. We were 0.04% above average. The one that stands out the most, we kind of saw as we were putting our data in, was in 2007 rather. 10.5, that was a bit of a dip. That was a bit below average, and we see that by the residual negative 1.13. And so we can see our residual plot down here. Since it's random, some above the x-axis, some below, that tells us that a line was a good thing. So our residual plot kind of confirms that r squared was so close to 1. So this is a really helpful tool to get all the information that we need from a linear